Welcome to the Configuring an OSPF-based IP Fabric Underlay Network module. By the end of this module, you should be able to explain how to configure an OSPF-based IP Fabric Underlay Network. Here in the exhibit, you can see the example topology. All routes are configured as part of the OSPF Area 0. Server 1 is single home to leaf 1, and Server 2 is single home to leaf 3. The network segments and loopback addresses within the IP fabric are also shown. The links to Server 1 and Server 2 are configured as part of the OSPF domain, but are configured in passive mode. Passive mode enables the advertisement of the networks connected to the passive link into the OSPF domain, but does not establish an OSPF neighbor, nor does it accept an attempt to establish an OSPF neighbor across the passive link. On the spine nodes, the fabric interfaces are configured under OSPF Area 0. The loopback interface is also configured under Area 0. A similar configuration is implemented on all spine nodes. On the leaf nodes, the fabric-facing interfaces are configured under the OSPF Area 0. The loopback interface is also configured under the OSPF Area 0. The host-facing interface is configured under OSPF Area 0 and is configured as a passive interface. This configuration places the interface and connected networks within the OSPF domain, but no OSPF neighbor will ever form over this interface. A similar configuration is implemented on all leaf nodes. In this example, although leaf 2 doesn't have hosts connected, it shows the configuration for connecting to the spines. Because leaf 2 is not on the shortest cost path between leaf 1 and leaf 3, transit traffic will not be forwarded across leaf 2. However, if hosts are added to leaf 2 in the future, and if leaf 2 is already a part of the IP fabric, only the host-facing interfaces will have to be added to the OSPF domain. Here, you can see that the OSPF protocol has advertised directly connected host networks within the OSPF domain. Note that on leaf 1, OSPF has advertised 2 next hops to reach remote network 10.1.2.0/24. A single active next hop has been selected. At this point in the configuration, the next hop of 172.16.1.17 through interface GE002.0 is the only next hop that will be used to forward traffic to 10.1.2.0/24. The alternate next hop, through interface GE001.0, is a backup next hop. If you examine the forwarding table, also known as forwarding information base or FIB, you can see that only a single next hop to destination 10.1.2.0/24 is installed. This next hop corresponds to the next hop that was selected by OSPF as the active next hop. A primary goal of implementing an IP fabric is to utilize all available paths for forwarding. The default behavior of the Junos OS is to install a single next hop to each destination in the forwarding table. To use multiple equal cost forwarding paths, you can override this default behavior through policy. The example shows a routing policy used to implement load balancing among all available equal cost next hops in the routing table, also known as Routing Information Base or RIB. The policy load balance has a single term named Term 1, which has an action of load balance per flow. Note that there is no from statement in the term. The absence of a from statement indicates that the policy will match any route without any conditions. This policy will match any route in the routing table, and if the route has multiple next hops, all next hops will be accepted by the policy. If more granular load balancing is required, a from statement can specify additional match parameters to select to which routes the policy will be applied. The policy is applied to the forwarding table to override the default behavior of exporting a single next hop from the routing table. To apply a policy to the forwarding table, apply the policy as an export policy at the routing options forwarding table hierarchy. Here you can see the results of applying the load balance policy to the forwarding table. An examination of the forwarding table shows that a ULST has been created for the destination prefix. A ULST is a list of unicast routes. The list contains all equal cost next hops that are present for the destination prefix in the routing table. EBGP-based IP fabric underlay